Okay, guys, we're back for Geometric Sequences in Series. It's Mr. Morrissey. I hope you're having a wonderful day. If it's past, I'd say 9 o'clock p.m., that's a little bit too late for you to be doing your work, so you can get it done earlier. See if you recognize this one. Anyone recognize this song or this remix? Alright, today we're looking at geometric sequences in series. And I assume now you're in the habit of reading over the notes that precede example number 1. And you're also in the habit of pausing. And you're ready to go. Alright, here we go. Find a rule for the nth term of 4, 20, 100, 500, ... Then find the third term. Well, you're saying, oh, Mr. Morris, is that a typo? Well, the third term we know is 100, but we're going to find the rule and then make sure the rule gives us 100 for the third term. So this idea of common ratio, that's the ratio between successive terms. So 20 over 4, 5. 100 over 20, 5. Common ratio is definitely 5. So you take the first term, which is 4, and each successive term is multiplied by 5 to the n minus 1. There's my rule. Now let's make sure that a sub 3 gives us 100. Three minus 1, last time I checked, was 2. And there's 100. Done. Cool. Okay. Let's see. Let's go to example 2. So two terms of a geometric sequence are the third term, a sub 3, is negative 48, and the sixth term, a sub 6, is 3072. Whoops, sorry. So let's see. A sub 1 is a sub 1. A sub 2 is a sub 1 times the common ratio. So a sub 3 is a sub 1 times r squared. So one equation we have is this. A sub 1 r squared is negative 48. Along the same lines, we would know that a sub 1 r to the fifth is 3072. System. So this is the second time a system has come up this unit on a video. It's probably important. So let's put this underneath. We're going to divide. So, don't know what that is, but if we were to take the time to figure it out, or just honestly throw it into a calculator, guys, you're going to get negative 64. Common ratio is negative 4. So for the rule, that would mean this. The first term, we don't know what the first term is, times the common ratio to the n minus 1. So I'm almost there. That's my rule, but I need to figure out what the first term is. So let's use the easier numbers. So let's see. Let's throw in negative 48 equals the first term, what we're looking for, that's a sub 1, so whatever that is, oh, that's 3. So negative 3 is the first term. So we just read the question one more time. You know, one thing that a student does that I really like, do I I have a highlighter? I don't have a highlighter here. Actually, yeah, I do. Hold on. One thing that I really like that a student does in one of my classes is highlight exactly what the question is asking you to do. So find a rule. I think that might be a good strategy for people to do. Like for example, on a recent quiz, there was a question, find the range and the domain. And the person just found, I think, the domain and didn't find the range. If you highlighted those two things, you would know, oh, I got to find two things. Recommend doing that, highlighting what the question is asking you to do. So the question is asking us for a rule. So we have this. And I know I don't have to point this out, but just to be absolutely sure, you would never do -3 times -4 and say 12 and to the n minus 1. Never. Big mistake not following the order of operations. But I just wanted to throw that out there just to, be absolutely sure. So this is our rule right here. Okay. Okay, now we're going to prove the sum of a geometric series. The sum is the first term times 1 minus r to the n divided by 1 minus r. All right, let's write out the sum of just a general form. So the first term plus the second term plus the third term plus the last term. And then we have to do a little manipulation here. If we were to say now, okay, well, let's write -r times the sum. For example, take this first term and multiply it by -r. Well, if we do that, I think you're going to see that we're going to get this. So I just took, I'm about to sneeze, a sub 1, there it is. Sorry, guys. Whew. So here, a sub 1 times -r is negative a sub 1r. A sub 1r times -r is minus a sub 1r squared minus ... And the last term, if I take this term right here and I multiply it by -r, I'm going to get minus a sub 1. Remember, there's a positive invisible 1 on the exponent on the r. So 1 minus 1 is 0. So the last term is r to the n. I better make that a little more clear. Minus a sub 1 r to the n. Just like in yesterday's notes, or the last set of notes, we're going to manipulate this. So we're going to subtract here. Or no, we're going to add here. S sub n minus r s sub n equals. If we add here, add here, add here, add here, add here, we add all the terms together, we're going to have the first term, and then we're going to have the last term. Factor out an s sub n. Divide by 1 minus r, and also factor out an a sub 1. So this is saying, which we just proved, the sum of a geometric series is the first term times 1 minus the common ratio to the number of terms divided by 1 minus r, which is right here. Oh, by the way, you don't have to memorize these, okay? I provide the formulas for you. All right, we are done with this first half of geometric sequences and series.